Hello everyone, my name is Manasherov and my colleague is Elad. In this video, we will show you a project that we have created as part of an advanced software development course, which featuring a variety of different design patterns and based on MVVM architecture. In the project, we have created a flight simulator controlling application using a client side with GUI and server side to calculate the shortest path to our destination. And supervised takeoff by loading an autopilot script which stabilize the plane at 500 feet above sea level and also give us the option to control the airplane manually with a joystick. So our project is combined from 5 milestones. Milestone number 1 is creating server-side using GRASP solid principle. Milestone number 2 is implementation of a server solver with a cache manager file and socket streaming. Milestone number 3 is algorithm implementation like A-star and BFS. Milestone number 4 is a custom language interpreter converting text to commands with a command pattern. And milestone number 5 is creating a GUI desktop app to the simulator using JavaFX. So let's start.
So first of all, we want to run the server.bat file. Now we can see that the server is running, and now we want to run the client.bat file. Now the application is running. So first of all, we want to load the data. Here we have the map of Honolulu, and we have loaded the map. All the red, this is the lowest places on the map, and the green is the highest places. So we have the map, and now we want to calculate the path. So we push it. Now we want to put the IP address and the port and press connect. So now we can see that the client connected to the server, and we want to push anywhere on the map to be the destination. Let's put here. So we pressed, and this is the route from here to our destination. This is the shortest path, and it's using the algorithm of BFS and A-star to calculate it. So now we want to press the autopilot and load the script to take off. You can see that the script is loaded, and now we want to go to the application. Here's the flight gear application. Now I'm going to press the fly, and it might take a bit, and so be patient.
Welcome aboard. Need help? Please help tutorials.
Great. So now flight gear application is running. You can see the airplane. Now we want to start the engine on. Great. The engine is on, and Now we want to connect the simulator by using the IP address and the port, pressing connect, and now we want to check here. Let's see when it's going to take off. Might just take a while. Here we go. So here we can see those numbers. Those numbers, that is the altitude of the airplane. So we want to reach 500 meters, and now the airplane is running on the land. When it will start to take off, you will see the number here rising till 500, and then it will print down, like here. Here it's starting to take off, and we can see the number start rising. Now using the autopilot, the number will start rising till 500. We're almost there. Just a bit. Great. So, done. We are at 500 feet, and now the airplane is stabilized. So, now we want to check the manual system. We'll transfer it to manual from autopilot, like this. But first, we want to write the throttle, manual. Now we're controlling manually on the airplane. You can see, using the joystick, we have right, left, down, and up. And using the rudder, right and left. So like this we control the airplane. Great. The server contains client handler and use of its inheritance techniques while implementing grasp and solid principles. It focused on an open-close principle so that we can give various implementations to client handler and solver. In order to avoid repeated calculation, we are using the file cache manager. By two interfaces, searcher and searchable, in the use of bridge design pattern, the searcher is actually responsible for implementing the search algorithm in general, and the searchable is responsible for adjusting the solution given to the search problem, like a metric search that we have in this project. We use the architecture of MVVM, model view, view model. The view basically holds the UI logic to basically everything the user sees. We used all the advantages of the XML file. The view is an observer of view model, which is sending notification and information to him. The entire information passes between them, and with data binding for saving uses in redundant parameters and functions. The view model is observing the model and receiving notifications from him about the end of calculating operations, which the view model transferred to him as a commands that occasionally might be complex and might be a long running time, like calculating path in a different thread for an instance. Thank you everyone for watching us.